Hi, welcome to the fourth edition of Distinti's Rules of Scientific Acquisition. This is rule of acquisition number 3, the Utility Fallacy, where rule number 3.0 is monkey do does not mean monkey know. It's a commonly held fallacy among people that technical marvels like airplanes flying through the sky and computers and spaceships prove mankind's mastery and understanding of nature. Let me tell you the truth here. Humans can develop wonderful technologies from physical phenomenon without ever having to know what the physical phenomenon truly is. And let me give you some plain, in-your-face examples. Exhibit A, fire. Fire has been used effectively for over 100,000 years. I thought it was 20,000. I looked it up. We've actually been 100,000. There's even evidence of going back millions of years that there might have been fire use. Okay, but 100,000 years ago is the definitely understood, believed, at least it's been that long. Okay, and humans have been using it to heat our homes, illuminate our homes, cook food, burn down the crops and homes of our enemies, murder people, blah, 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 blah. And all in that time, there were many wrong theories about what fire was. And here you have the alchemist symbols for fire, yada, yada, yada. Some people thought fire was alive. Some people thought fire was a chemical, was an element, a fundamental element of the universe. But our lack of knowing what fire was, or is, did not stop the Bronze Age, the Iron Age, the firearms development, the Steam Age, and even didn't stop the Industrial Revolution. We did not know, we still didn't know, the Industrial Revolution started in the early 1800s. We didn't really understand what fire was until the last half of the 1800s. Okay, so we put fire to great use, doing wonderful, fantastic things, all the while not really knowing what fire was. Okay, so you don't have to know what something is to put it to great use. Utility is what we're getting out of fire, even though we had no idea what it is. So just because we can put fire to great utility does not prove that we know what it is. Monkey do does not mean monkey know. But one thing we have to ask ourselves, do we truly know what fire is? And we know that fire is a chemical reaction, but what are chemical reactions? Something to do with the nucleus of the atoms? That's what we're trying to figure out now. So just because we know one echelon of detail doesn't mean we know what the echelon below that or below that or below that. You know, fire is a combustion involving atoms. What are atoms? We don't know that yet. We really don't know. We got models and theories, but we don't know for sure yet. Okay, so we don't really know much about anything, even for all of our technological prowess. So, rule of acquisition 3.1. Technology is an extension of our ability to mimic. It is not proof that we understand. Let me give you another example, electricity. You know, we've got computer chips and we've got electric power. We're lighting the night and we're doing all this radio communications and yada, yada, yada. And here we have Coulomb's model. They call it Coulomb's law, but it's not really a law. It's really an empirical model. Okay, what this is some Yahoo a couple hundred years ago, long before we understood what fire was, we were developing models of electricity, ironically enough. Okay, and so they took two charged spheres, measured the distance between them, put a certain amount of charge on one, a certain amount of charge on the other, and then they measured the force between them. Then they did it a whole bunch of different times and found that it followed an inverse square relationship. And then they made a big old honking constant of relation to make it all work. So my friends, this is really an empirical model. This is developed from empirical data. This isn't a fundamental law of the universe. Why physicists call it a law is totally a sham. It is not a law. It's an empirical model developed from empirical data. This is nothing more than us mimicking what electricity does. It does not tell us what electricity is. This is just an extension of our ability to mimic. That's all science is. Science is monkey see, monkey do. Okay, this does not tell us what this magical thing is. It traverses from one charge to the other and somehow couples to it imparting force. It doesn't tell us how fast it gets there. There is so much missing information here. And that's why I developed Ethereal Mechanics, to try to give a model for it. Not to try to come up with a model that explains what this truly is. My models are coming to the conclusion this is really magnetism in disguise. Okay, but the point here is that this does not tell us what electricity is. And when I try to tell people, they could be, oh, you don't understand what electricity is. I'm like, that's exactly what I'm saying. And they think because we do all this stuff that we know what electricity is. We don't. We know what electricity does. We don't know what it is. That's a very important distinction. The problem, the dark side of all this, the reason why there's a problem here is because if we think we know what something is, we stop looking at it. We think, oh, we're done here. There's nothing else to learn here. I'm like, there hell of a sure is. We need to understand what that magic thing is. It goes across space and affects the other charge. We need to understand how fast it goes. What is it? How does it couple? Where does it get its energy? What does it manifest? There's so many wonderful, interesting questions here to ask. But what we do is, because we get such great success with electricity, we shut down and we say, oh, we're done here. There are so many wonderful things we could learn just by some simple experiments and study. So the dark side is because we think we know what we're doing, we believe we're done, we stop asking questions. And so the greatest rule of acquisition 3.2, the greatest obstacle to scientific progress is the delusion that we think we know what we're doing. Let's go further. This is the chemical symbol, the mimic. This is a model that mimics the structure of salicylic acid. Or salicylic acid. Salicylic acid is found in the bark of willow trees. It was discovered by accident by Native Americans to be something as an analgesic. And so modern science basically played around with the molecule a little bit and pulled off one thing, added another thing, and invented acetylsalicylic acid, which is pretty much aspirin. Okay, and that's all we've done. Is we kept just changing around the molecule to see what we get. We have no understanding what we're really doing. We just do random stuff, and then we find some chump to go take the medication and see what it does. Okay, we change it around again. We get acetaminophen. We change it around again. We get ibuprofen. Okay, that's all. And same with designer drugs out there. People are just taking cocaine and morphine, all that. They're just changing up the molecule to get around the law and seeing if they can still get high from it. That's all they're doing. There's probably 1 billion isomers, I guess is the right word. I don't know if that's the right word, but chemistry, we take the ethylene molecule, which is 2 carbon atoms and 4 hydrogen atoms, and then somebody said, well, what if we could strip off the hydrogen and put fluorine atoms there? This is the same. There should be C's here, but this is a different representation of the same. And then we got tetrafluoroethylene, Teflon. This is Teflon, discovered by accident in 1938 by Roy Plunkett. Again, we're discovering stuff by complete accident. We don't know what we're doing. Nuclear power. We know enough of the conditions under which radioactive materials decay. Again, we're mimicking. To allow us to build bombs and power plants. However, we don't really know why things decay. We really don't know what atoms are yet. And we're playing around with nuclear power. And that modern fission reactors are only about 2% efficient is evidence to me that we really have no clue what we're doing. In fact, this concept got spun off as the 20th rule of acquisition, which is called the poor efficiency tell, where I make a claim that a technology that is below a certain percent of efficiency means we don't know what we're doing, and above a certain percentage, we can have good confidence that our models are useful. Maybe they're not the true reflection of the true underlying natural phenomenon, but knowing the true underlying natural phenomenon will not improve what we're doing right now. Okay, and so that's called the poor efficiency tell, which tells us we have more to go if our efficiencies in some technology are too low. And, we think we know everything about nuclear power, but we can't get a fusion reactor to work on the frickin' Earth. That shows you how little we know what we're really doing. You can put all the FUDs in the room you want, say, no, we know exactly what we're doing. I say, no, you have a theory of what you're doing, but if you can't get a fusion reactor, all bets are off that you know what you're doing. But the key insight here is we really don't have to know much about something in order to put it to great use. I mean, look at you. You use a car every day. You don't have to know how an internal combustion engine works. You don't have to know how the ignition system works. You don't know how to vulcanize rubber and make tires. You don't have to know any of that stuff, and you can put a car to great use. Same with a smartphone. And how do you learn how to use these things? You watch somebody else and you mimic. So our fabulous ability for mimicry gives us the false impression that we really understand what it is that we are using. So conclusion. Science is monkey see, monkey do. However, monkey do does not mean monkey know. Now it's important that we do this. We have to be honest about what we know and don't know, because then we can look at things more objectively to determine, hey, we don't know something here. That means there's something left to do in science. We're not done. And it opens up doors that we thought were closed because we thought we knew everything. That's why these things are important. It's not to be putting humans down. It's to put things in a proper perspective, to give us a tell, to allow us to see things that we might have overlooked because we thought we knew what we were doing. This is the reason for the rules of acquisition. I am a retarded monkey. I admit that. By admitting I'm a retarded monkey, I have come up with the rules of acquisition to compensate for the deficiencies of the retarded monkey brain, to allow us to improve our capabilities in science in spite of the deficiencies of our retarded monkey brains. Okay? By doing that, you have to be honest about what we can and cannot do. We have to be honest about things that confuse us. Okay, and that's one of the major reasons for the rules of acquisition, is to help us make better use of our retarded monkey brains by identifying the flaws in the retarded monkey brain. Thank you very much.